Well, hello, amazing people. You're welcome to the subsequent video, which is actually the second in this series for the mole. In today's video, we're going to be talking about the molar mass. So let's go right into what we have for today's video. And by the way, this is the second video in this series. Now, we want to start today's video by defining something very, very important, the relative atomic mass. What does this mean? Now, first things first, the relative atomic mass tells us something in science or chemistry. It tells us how heavy one atom is compared to another atom. Now, think of it like the body weight. If I have a student or I have a group of two students, the first student weighs 50 kg and the second student weighs 100 kg. You will immediately know that student B is heavier. Why? Because his mass is greater when compared to the first mass. That's the same idea about the relative atomic mass. It is a measure that tells us how heavy an atom is when you compare it to another atom. So here is an example to buttress what I'm trying to say. In chemistry, the element hydrogen has a relative atomic mass of 1, and oxygen has the relative atomic mass of 16. What does this mean? It means that when you compare the relative atomic mass of oxygen to hydrogen, hydrogen has the relative atomic mass of 1 and oxygen has that of 16. It means oxygen is 16 times greater when it comes to atomic weight than hydrogen. It is as simple as that. Now, there's something important you need to know, okay? Some of you might be thinking, well, how do I commit all these values to my mind and know them by heart? Oh, you absolutely do not need to do that. If you can, by all means do. But all these values are already given to you on the periodic table, and you are not expected to memorize them all. So just do well to enjoy your periodic table. I have a draft of one on the screen right now. Uh, Let me try and zoom in a bit. So you can go ahead and check out any elements you'd like to see, whether it be hydrogen, lithium, beryllium. All the atomic masses have been given on the screen. So let's go ahead and check out some exercises and we'll round up today's video. The molar mass of a chemical compound or an element can be calculated in a series of steps. Calculating the molar mass step by step. Now, the molar mass of a compound is simply the mass of 1 mole of a substance. In the introductory video of this series, we talked about what the mole is, and the unit is measured in grams per mole, G per mole. That's how it's written. So the golden rule is to add everything, and I'm going to be showing you how the molar mass an of a compound can be calculated. The first thing you need to do is to write the formula, step 1. Step 2 would be to find the relative atomic mass of each element. This symbol AR here simply means the relative atomic mass of that element, okay? So the third step would be to multiply by how many atoms of that element are there, and then fourthly, you add them up together. So let's see if we can do justice to a number of examples. We have the first example, which is water H2O. Let's see if we can calculate the relative or the molar mass of water. So the step 1 is to write the formula. The formula is H2O. The step 2 would be to find the relative atomic mass of each element. Hydrogen has the relative atomic mass of 1. It's given over here. And oxygen has the relative atomic mass of 16. So that's step 2. Step 3 would be to multiply each element by the number of atoms that are present. Now, from the formula H2O, we can see hydrogen having 2 atoms present, denoted by this subscript of 2. So that means for hydrogen, it will be equal to the mass, which is 1, multiplied by the number of atoms that are present, which is 2. And then oxygen, we can see from the formula that oxygen has only 1 atom present. So the what goes for oxygen will simply be the number of atoms present, which is 1, multiplied by the mass, which is 16. So for hydrogen, we have 2, and for oxygen, we have 16. The fourth step would be to add everything together. We have 2 plus 16, and that gives us 18 grams per mole. This is the molar mass of water that we've just calculated. I hope you saw how all the steps were carried out. Now let's do the same thing for carbon dioxide. Step 1 will be to write the formula CO₂. Step 2 would be to find the atomic mass or the relative atomic mass of each element. Carbon has the relative atomic mass of 12 and oxygen has the relative atomic mass of 16. The third step would be to multiply each element by the number of atoms that are present. From CO₂, we can see that carbon has just one atom. So for carbon, it becomes one atom multiplied by the mass, which is 12. And for oxygen, we have two atoms of oxygen present, shown by this 2. So it becomes two atoms of oxygen multiplied by the relative atomic mass of oxygen, which is 16. So for carbon, we have 1 times 12, which is 12. And for oxygen, we have 2 times 16, which is 32. And the fourth step would be to add everything together. So we have 12 plus 32, which is equal to 44 grams per mole. This is the molar mass of carbon dioxide. I hope you saw how all the steps were carried out. So we're moving on to what we call hydrated compounds. Now, don't get confused, okay? These new words that I just introduced to you are simply terminologies that are used to identify a special type of compound in chemistry. Hydrated compounds are simply salts or compounds that carry water of crystallization. How do you know? You will always find H₂O inside the symbols for their compounds. So here is a very good example. We have this compound over here. That is a good example of a hydrated compound. How do you calculate the molar mass of a compound like this? It is easy. We do the same thing that we did in the previous question. Now think of it like this. Let's give an interesting analogy that you can relate with. Let's say you bought a bag of rice. Over here, we have a picture of a bag of rice, and it came with 5 sachets of pepper that are attached. And I ask you, what will be the mass of everything you bought? You will just simply add everything together. The mass of the pepper and the mass of the rice, you add everything together to give me the total mass. The same thing applies to this hydrated compound over here. To find the molar mass, you simply get the molar mass of this compound, get the molar mass of this compound, and you add everything together. So let's go ahead and see if we can do justice to this question. First thing to do is to write the formula for the compound, which is step 1. So we have CuSO4 5H₂O. That's step number 1. Step number 2 would be to write the atomic masses for each element that are present. So we have the first element, which is copper, Cu, and it has the relative atomic mass of 29. And we have sulfur having the relative atomic mass of 32. Let me underline them as I take them each step of the way. Sulfur. And then thirdly, we have oxygen. Oxygen has the relative atomic mass of 16. And then we have hydrogen, which has the relative atomic mass of 1. And then that's all. We have oxygen over here, but we've already handled oxygen. Now, the next step, I want you to follow me carefully, would be to multiply each element by the number of atoms that are present. Now, how many atoms of copper are present in this compound? If you check carefully, you will see that copper appears only once, which is over here. So that means copper will be multiplied by 1, which is equal to 29. If you check well also, you'd see that sulfur appears only once as well. So it will be 32 multiplied by 1 as well, which is equal to 32. I hope you're following every bit of this lesson. By the way, if you're enjoying it, it will do me a world of pleasure to have you like, share, and subscribe so you can get more amazing content coming your way every day of the week. Now, next element we have is oxygen. How many atoms of oxygen do we have? We can see oxygen having a subscript of 4 over here, which means we have 4 atoms at first. And then over here we have the symbol of oxygen as well. And there is a coefficient of 5 that affects it. So that becomes 4 atoms plus 5 atoms, which becomes 9 atoms altogether. So we have 16 multiplied by 9. 16 multiplied by 9 gives us 844. And then finally, we have hydrogen. How many atoms of hydrogen do we have present? You can see hydrogen over here having a subscript of 2. So we have 2 atoms multiplied by the coefficient, which is 5. That gives us 10 atoms of hydrogen present. So we have 1 times 10, which gives us 10. The last step would be to add everything together. So we have 29 plus 32 plus 144 plus 10. Adding everything together gives us 215 grams per mole. That is the molar mass of the compound that we just encountered right now. I hope you're enjoying every bit of today's lesson. So here is an exercise for you to carry out. I'd like you to drop the answer in the link that is provided in the document that you downloaded or in the comment section if you're watching this video right now. Here is the compound and here are the details that you need. Calculate the molar mass and let me see the answer in the comment section. Up next, we're going to be dealing with something very, very interesting. The lesson is progressing and I know you are too. It's called the golden triangle. I can't wait to see you in that lesson. By the way, my name's David and I'm an online chemistry tutor for high school kids. If this lesson was interesting for you, I'd like you to please do well to like, share, and subscribe, and I'll see you in the next video. Thank you.